Hi children, this is your physical science facilitator, assessed from Commander Group of Schools. Welcome to the online classes. What the pointer is doing, children? Yes, it's moving. Okay. What the duster is doing? Rubbing means it is also moving. Okay. So these objects are under movement. Means what do you call that? Yes. This is our topic, motion. What is meant by a motion? So before going to know something about the motion, you should know what is physics. What is physics? What do you call the physics in Telugu? Bhautika Shastra. Yes, correct. Physics means which can be appear, physically appear. Physics, Bhautika. So, I would like to ask one question to you. What is the shape of this duster? Rectangle, okay. What is the shape of this ball? Sphere, okay. How you are going to answer all these questions? By seeing, yes, by observing. So there are several definitions are there for physics. But the classical definition, the fundamental definition of physics is about the study of visible substances with evidence. So many definitions are there. It's about the fundamental definition. The study of visible substances with evidence. You said that it is a rectangle. By observing you are going to say, what is the evidence? This length is different from the breadth. So that is the evidence which applied here by physically observing. So physics is nothing but the study of visible substances with evidence. In this physics so many branches are there. Among them mechanics is a very ancient branch. This motion will come under that mechanics. Right. So for example, if any body is under motion, what are the fundamental things you have to be recognized? That there should be change in the position of the object continuously with respect to time. For example, here the duster is at point A. The duster is at point A. After few seconds, the position has changed to B with respect to time. Then we can say that the object is under motion. But it is not enough to define the motion. But generally we can say, when an object changes its position continuously with respect to time, then we can say the body is under motion. So, it's first definition of the motion. What is the definition of motion? A body is said to be under motion. A body is said to be under motion when it changes its position. It changes its position continuously with respect to time. Okay. But for example, all we are going to an excursion in a bus or in a train. For example, children, you are sitting in front of me. I am sitting in this side. The train is going with 60 km/h. The train is moving, but with respect to me, you are always in front of me. Even though the train is moving, with respect to me, you are under rest. So, if you want to define the rest, we must go the relative word rest, motion and rest. If you want to define the motion, suddenly you have to go for rest. So this motion and rest, these two are relative terms. I will give you a small example for the relative terms. Why we have to focus a lot on this position or nothing but reference. Here there may be a small home like this. A small home is there, and it may be the road. And two members are coming. one person is coming in this direction. For the reference, I am giving it's north, east, west and south. So now this person B is moving from east to west, and I am going to take one more person here. He is moving like this. Means from where to where? From west to east. For this person A, the house is left side. For the person A, the house is left side. For the person B, because he is going from east to west, for this person the house is in right side. House is same. The position of the house is same, but with the reference of B, it is in right side. With the reference of A, it is in left side. So, at a particular time, at the same time, the position might be changed with respect to observer. So, it is very crucial from where you are observing and how you are observing and how you have to define the motion. Okay, right. So, similarly, if you see one more example. Like this, there may be a boat, here like this, a boat on river Godavari, and just beside that some mountains are there, like this, mountains are there, we call it as a poppy border, generally poppy border are there. This side also, the mountains will be like this. Here, two persons are very good. Sitting over there, two persons may be A, B, and it's about the bank. On this bank, two more persons are there, maybe C and D. See here, this boat is moving. The boat is moving like this with some velocity, maybe 30 kmph or 20 kmph like this. The boat is moving. For example, if the person C want to explain about its position to D, what he will say? He said that the boat is moving. The boat is moving towards west. And what about this person A will say with respect to this B? For example, I want to notice the position of B. I want to know the position of B only. What the C will tell about the position of B? The B is moving towards east. If the same person is observed by this fellow A, with respect to A, what about the position of B? It will be rest. So, the position of B with respect to A is at rest, and with respect to C, the B is under motion. So, with the reference, the motion can be defined. So that the definition of the motion has changed like this. What is the previous definition? A body is said to be under motion. When there is a change in the position, continuously it's going to be changes now. For example, here the destiny is here. Now it is moving up to here. So the position has changed. The position has changed from here to here with respect to time. That is the previous definition. But what is the definition now? A body is said to be under motion when there is a change in the position of the object continuously with respect to time and reference. Without reference, you are discussing and you are learning motion is a nonsense. Okay, so referential point is very crucial while you are learning about the motion. So what is the new definition of motion? A body is said to be under motion when there is a change in the body, in the position of the body continuously with respect to two things. One is about time, and the other one is reference. So with the help of reference only we are going to say, with respect to A, the body B is under rest. With respect to C, the body is under motion. For example, if the bee is going to observe these mountains, the bee is going to observe the mountains, what he will say? The mountains are moving. Suddenly he will say, because the boat is moving. But what about this bee will say about the mountains? The mountains are at rest. So, with the same referential point, different objects may be under motion, may be under rest. So, if you want to explain about the motion, the referential point are going to play a vital role. Okay, right? So, in day-to-day life, we are observing so many motions. A person walking, car is moving, train is running, an object thrown into air, so like that, so many examples are there. But, and how you have explained the position of an object on the surface of Earth? What is the shape of Earth? Yes, spherical, of course, not exactly sphere, but generally we consider it as a sphere. And how are you able to identify the position? For example, I am going to take a ball, let us consider maybe the Earth. It is the Earth. Okay. If this red pin is you, when I am going to ask the question, where you are, Mr. Red Boy, where are you? That is the question. You may say that I am top. Because you are observing some other. For example, I want to ask the question, if you are going to consider it is an earth, what is your position? Because sphere is a directionless. For example, I am going to write one shape here. It's about a shape. Okay. So, if I want to observe with respect to x-axis, its shape is like this. At the top something, at the down something. If I want to observe with reference as the y, with respect to y-axis, entirely different. The shape is not unique. When I am going to observe with respect to x-axis, the down is different, top is different. When I am going to observe with respect to y, this plot and that plot is entirely different. If I observe with respect to z-axis, that is also entirely different. If I want to observe the same thing, see a sphere. Can you understand this? How? For a sphere, let us consider it's a sphere. For this sphere, I am going to draw the axis, maybe x-axis. With respect to x-axis, same size. With respect to y-axis, same. With respect to z-axis, same. So with respect to any axis, it appears as usual. So it is a directionless. The sphere is a directionless. Before I draw one dumbbell, that is differ with respect to x-axis and the y-axis. Like this. If you observe with the x-axis, like this. If you observe with the y-axis, it is like this. Okay. So it is differ. It is differ. Now the earth is also sphere. For a sphere, without knowing the referential point, if you are going to say where you are, how it is going to possible? For example, you are going to say it is the top. It is continuously rotating. So the point which is top, which is down, which is side, it's very difficult without any reference. Okay. If I am going to ask, maybe you are in AP, maybe in Tirupati. What is your position on the surface of it? Maybe top, bottom. How you are going to say? It's difficult. Okay. So, here you may see, if you say at the top, it is the top, it is the bottom. Now, where you are? You will be here. So, here without any reference, if you are going to keep a dot, we are unable to identify the position. Okay, so if you want to identify the position, there must be a referential point from where you are observing. For example, you are the observer from maybe at Dubai. From Dubai. So from Dubai to India, or maybe from Sri Lanka to AP. So if you want to observe, the referential point is very crucial. Okay, so I think you've understood. If you want to explain the position or the motion two things are essential. What are those? Is time and referential point. Okay. Now let us see the fundamental physical quantity. Means we are going to start the lesson about that. Distance and displacement. Distance, displacement. Very easy concepts. Distance. Distance is nothing but the entire path covered by a body. The entire path covered by a body. For example, here maybe point A and here point B. A person starts from here moving like this and moving like this and later he reach B. So here the entire path, this is the entire path covered by the particular object. So the entire path covered by the body is called as distance. Then what is the displacement? For example, similarly here point A is there and point B is there. So the displacement is nothing but the shortest distance. The shortest distance between initial and final points in a specified direction. In a specified direction. Or the shortest distance between 2 points in a specified direction. So we are including one more thing here, direction. Okay. So what is by distance here? The entire path covered by the body. The entire path covered by the body. Maybe from one point to another point. Now, the shortest distance between the 2 points, the shortest distance between the 2 points in a specified direction. In a specified direction is going to be considered as displacement. Commonly, students may know very well about this distance and displacement, because in the school it's maybe the classroom, it is a point of classroom, and it may be the washrooms, it may be the washroom. So when you are going to the washroom, it is about displacement. Directly you will go from class to washroom. But when you are coming to the class, you will go to another section, another class, another room, staff room where the teachers are there or not, and somewhere else. And finally, again we make a round. What is the other class? Okay, what is the next class? Who is the invigilator? All the things, and you will go to your class. So it is about the displacement when you are going to the washroom. And it is about I have not no directions here because you are moving randomly here to there, the entire this path covered. So when going to the washroom is the displacement, coming to the class is distance. So entire path covered by the body is going to consider as distance. And the shortest distance between the points in specified direction is correct, displacement. Now here the distance is a scalar quantity. What is a scalar? The physical quantity which has only magnitude. The physical quantity which has only magnitude. What do you call that? Scalars. So here, if you want to represent about the distance, for example, I am going to ask one question to you. What is the distance of your house? You may say 2 kilometers. I am asking only distance. You will say just 2 kilometers. From this point, I will go like this 2 kilometers. Is I am going to get their home because his home is maybe in this side. So the information what given by the particular fellow may not sufficient. So he may say, where is your home? Is 2 kilometers towards east. Towards east. So here just 2 kilometers. Only magnitude is there. Only magnitude is there. That's about distance. So here 2 kilometers towards east. Towards east. So direction is also mentioned. So displacement is having both magnitude and also direction. Magnitude and direction. The physical quantity which has both magnitude and direction are called as vectors. What do you call that? Vectors. Whereas this one is a scalar. Why it is a scalar? Because it has only magnitude, no direction. The physical quantity which has only magnitude but no direction. What do you call that? Scalars. So here distance is a scalar. And what about displacement? Displacement is a vector. Displacement is a vector. Why it is a vector? Because it has both magnitude and direction. And the units, both are measured, maybe in SI system meters and in also in meters. Okay, if you go for CGS, centimeter and of course centimeter. Kilometers, like that, so many other astronomical units are also there, light year. Okay, so let us see once again the main concept of words. Distance means the entire path. The entire path covered by the body is called distance. Displacement means the shortest distance. The shortest distance in a specified direction. In a specified direction. Okay? So entire path covered by the body is called distance. The shortest distance between the 2 points in a specified direction is called displacement. And it is a scalar quantity and it is a vector quantity. Why it is a scalar quantity? Because it has only magnitude, no direction. For this displacement we need both magnitude and direction. So it is a vector quantity. Here the units are unique, meters, here also the meters, or maybe centimeter, here also centimeter. Okay. Right. Commonly the distance is represented with the letter D and displacement represented with the letter S bar. S is the physical quantity magnitude and this bar indicates the direction. So magnitude and direction both is there for the displacement. Okay. So it's about general classification between the distance and displacement. Now let us see how this distance and the displacement is different. With a few more examples. Already I told you so many things. Let us consider a body A. Okay, body A is moving like this. Okay, from point P. From point P. After some time, the body A reaches the point Q. After that, it changes direction. Now it's moving towards east now. Now it moves towards north and reaches the point R. Here it may be 4 meters and of course it may be 5 meters. So like that. Now the distance covered by the body A, the distance covered by the body A, what I am asking? Distance. What is the meaning of distance? The entire path. What is the entire path? P to Q plus Q to R. It is the distance. It's about 4 meter plus 5 meter. So totally 9 meter is the distance. Then what about the displacement? What is the definition of displacement? The shortest distance between starting and ending point. It is the starting point, it is the ending point. What is the shortest distance? This is the shortest distance. In a specified direction. It is the starting point, it is the ending point. So we are giving arrow mark like this. So it is the direction from point point P to R. Now from here to here, it's about the displacement. See here it is a right angle triangle now. In the right angle triangle, according to Pythagoras theory, what is Pythagoras theory? Hypotenuse square is equal to side square plus side square. What is the hypotenuse here? P R square is equal to other sides PQ square plus QR square. Now what we need PR square or PR? We need only PR is equal to under root of PQ square plus QR square. So the displacement, it is about the displacement. PQ is about 4 square and it is about 5 square. Okay, so PR distance is about root of 16 plus 25 units. Whatever the units, meters is given, so meters. See, entirely different. It's about the 9 meters. It's about square root of
41.
41 meters. Okay, so entirely different. So distance is differ from displacement. We'll take one more example also. Have understood? Yes. So distance is entirely different from the displacement. Displacement is a shortest distance between starting and ending point in a specified direction. Direction is important. For example, an athlete start from here, point A, and the ground is just like circular, and exactly opposite from this point to A, he reaches point to B, exactly opposite. And what is the condition? It is a circular ground. Now, the question will be asked like this: what is the distance and displacement covered by the particular object? Have understood, bye? What is the shape of the ground? Circular. What is the shape of the ground? Circular. What is the condition given? It is the point A. He is running and exactly reaches the deadly opposite to this point A. Exactly opposite to the point A. Okay, so now he is here with respect to some time. Now, what is the question? What is the distance and displacement? For that, is going to give one more clue for us. It is a circular ground now, and this circular ground is having the radius of 14 meters. What is the radius? 14 meters. Okay, that is the clue given for us. Right, let us see first distance. What is the distance now? Entire path covered by the body. So from here to here to here to here to here to here. From here to here. What is the shape of the ground? Circle. Okay. What is the circumference of the circle? Circumference of the circle, because he is running like this. So he is going to cover the circumference of the circle now. Yes, 2 pi r. But what is the condition? He reaches exactly opposite. So he doesn't cover full circular round. He covered half of the circular path. Half of the circular path means 2 pi r by 2. So what is the distance he covered? Pi r. So distance covered by the particular fellow is about pi r. Distance is about pi r. But what is the r value? R value given as 14 meters. So distance d is equal to pi means 22 by 7 into r value 14. 7 ones 7 ones. So is about 44 meters. So the distance is about 44 meters. Right? Let us see the displacement. Displacement means S bar. S is the magnitude, bar indicates the direction. Right? So, what is the displacement? The shortest distance between starting and ending points in a specified direction. So, it is the starting point, it is the ending point. So, what we call this one? The point which is the line which is passing the center of the circle, no? Because exactly opposite. So, what we call this one? Diameter. So, here the displacement is nothing but diameter. It will be equal to the diameter. So, S is equal to diameter is nothing but, what is the condition we are having? Diameter is equal to 2r. Okay, so it is about S r plus r. Nothing but 14 plus 14. How much? 28 meter. So the displacement is just 28 meter, whereas the distance is about 44 meter. So the distance and displacement are not unique. The distance means the entire path covered by the body, and the displacement means the shortest distance between starting and ending points in a specified direction. Okay, in the circular path. Now, I am going to ask one more question. A person starts from A and running over there, and after some time he reaches A. What is the distance covered? What is the distance covered here? Yes, distance is equal to circumference of the circle. Circumference of the circle. Okay, so 2 into 22 by 7 into r. 14. 7 ones, 7 twos. So about 44 is 88. 88 meters. That is about the displacement. What about the displacement? Is about the distance, distance 88 meters. Displacement is about the shortest distance between starting and ending point. Starting point is A, ending point is also A. So what is the displacement? 0. So from this you can analyze one thing, the displacement may be 0. There may be the chances that the displacement may become 0. But what about the distance? It won't. And displacement may be negative. Displacement may be negative with referential point. The displacement may be negative with respect to referential point. But the distance never be negative. Remember, the distance never be negative. And based on this, once in competitive examination also they ask a very silly question. That's about which of the following is correct relation. Which of the following is correct relation? It's about distance. It's about displacement. Distance is less than to displacement. That is the first option. Distance is greater than to displacement. It's always. I'm going to add one more thing. Always. So distance may be greater than or equal to displacement, and displacement may be greater than or equal to distance. So like that the conditions are given in competitive examination also. What is your option? Distance is less than displacement. Previously also we saw that. Okay, so distance we got 88 something and displacement is 0. So it's not going to be, because shortest distance is the displacement. So distance most probably more. And distance is greater than displacement. Maybe chances are there. But I want to explain one more thing here. It is point A and it is the point B. A person is moves like this. What is the distance he covered? From here to here maybe 2 kilometers. He covered 2 kilometers. Or one more person starts from here and reaches to here in the same means shortest distance. Now it is also 2 kilometers now. It is the distance. I have not mentioned previously the direction. A person starts from here to here and covers this distance 2 kilometers. Starts from A and reaches to B in this particular direction. Now the distance is 2 kilometers, displacement is also 2 kilometers. Both are same. Both are same. But what is the condition given? Always. Distance should always be greater than displacement. No. There may be some chances to equal. When the moving path is in a specified direction, then the distance is going to be equal to the displacement. So in all the cases, this is not going to be acceptable. So that the condition which is given, always the distance is greater than displacement is not considered. Now, distance is greater than or equal to displacement. Greater. Just now we saw so many examples, certainly more. And in some specifications, in the same direction the particular body is moving, then it's going to be the correct. Here no chance of this, so displacement is always less than the displacement, distance. Okay, so what is your option? Third one. Distance is going to be greater than or equal to displacement. Have you understood? Okay. So in this session we learned something about what is motion and how we have to define the motion, what is the previous definition and change the definition, what is the rest, what is motion, what is the referential point, and how we have to identify the location, and two fundamental physical quantities about distance, of course not fundamental, but the comparisons of distance and displacements. Okay, in the coming class we will see the remaining topics. Thank you. Have a nice day.